So let's take a look into it. This very common scenario, you are the provider of some kind of microservice or some kind of API, and you have a bunch of consumers of your microservices. So a very common scenario if you program a microservice in your architecture. Now, just a reminder, what you eventually really want to have is a build train like this. You have some kind of CI build, then you deploy this stuff to staging or test environment or whatever, and then it's the main part here, you run test provided by all your consumers of your API, and then decide if you go on to live or not, a rollback. The main part is here, the consumer tests are set by the consumer teams because they represent their view on your API. But I'm not really talking about this, just keep in mind this is what you really want. What I actually want to talk about is what are the most common errors this kind of build chain really fixes or addresses. Well, this is really very common sense here. It's, you probably experienced this many times. First one is the data is just not there where it's expected to be, which might be a typo in a JSON path, a typo in the URI. The misunderstanding about the JSON hierarchy, we have seen several examples already in some talks already, or the data is not in the expected format, like, for example, someone uses string true instead of a Boolean true, or someone sees its timestamp and inserts a Unix timestamp instead of what you expect in ISO date time or other way around. And eventually, which are the hardest part is the consumer sends data to your microservice while your service is in some kind of wrong state because the consumer should have done something else beforehand, before this request. Well, how can you address most of these problems? And now you're probably throwing X at me because just provide documentation for your API. I should have stressed out the precise part here. Developers really love to read precise documentation. There's no developer out there who will say, oh, no, I have documentation, I don't want to read it. They love to read it, but they hate to write it. It's very common. I've never found a developer who's doing, we have to write documentation, do it later. No, I'm doing something else. And eventually, they forget to update it. So, how can we address this problem? Well, the first one, what you can do is you can document your API by example, which is very simple. You probably have your build chain and you write some kind of smoke test or component test, which you actually have in your build chain. You would be really, everyone should have something to test if your service is deployed correctly in your staging environment. Yeah. But what you can do is you can use some kind of BBD testing framework to write these kind of component tests. And then the main part here is log all your HTTP requests you are doing in this test, generate some kind of fancy report out of this, and then eventually just publish this report, which creates a story what you are doing with your API, how you think your API is supposed to be used. And optionally, you can even run all your requests through some mock proxy or packed proxy or something, and by this generate a mock for your consumers, which is, and yeah, let's see how this might look like. Hopefully you can read this. This is here an example. I'm using Cucumber JVM from the JVM. Some people already know that there's something like Cucumber. Most people don't know it's also available for JVM. And since I can't use the examples from my current project, I just have an example here from, let's say we have some kind of book database and we want to manage all sorts of books, such part of this book database. And yeah, you just write down your scenarios, what you want to do with your API. You just write down, I want to add or remove an author, and I asserts that there's some kind of connection to my book database, and I want to create when an author is created and so on. You probably have seen this kind of gherkin already. And then in your actual code, you write the actual implementation, what you want to do with your, how you do with the HTTP request down below. And instead of just using the HTTP client, I'm using here some kind of client. So this is a really, I hate to call it library, it's like 3 classes or so. It's a pimped up HTTP client, which is with which just logs all the HTTP requests to the Cucumber report. And the outcome of this would look like this here. I have here my Cucumber report, and here all my features, and here you see every HTTP request and response which is done in each step. And thereby I create a nice story what happened with my API. And this here I just publish on Jenkins or wherever else, and say if some consumer 4 comes along, I can say, hey, you want to do manage an author, here you can take a look. This is how we think you might do it. Maybe the consumer will come up with an entirely new way to do it, yeah, but and then you have to extend your tests because you haven't thought of a scenario yet, but wait, this is common source. And this here is always up to date. You can say this works here because it's green. Yeah? Otherwise, it would be red. Well, okay, this is just a starter. Yeah? This is just a way, it's a crude way to provide documentation for other people, but it's a really simple way to do it. It doesn't cost very much because this kind of test you would like to do anyway. So the next part. Provide an API specification. Well, there are or there were several ways to document REST APIs. I think what boils down is right now it's Swagger or RAML, in my opinion. There might be still something Waddle or something, but I think Swagger or RAML are the most sophisticated tools right now to document REST APIs in a clean way. But how do you keep this specification in sync with reality? Well, usually, especially with Swagger, the usual approach is that you enrich, or some people would like to say pollute your code with tons of annotations, and then generate your specification out of your code. Okay, in that case, your specification is in sync with your code, with reality. But, yeah, and another good part is that your documentation is where your code is, which is always good. But the bad part is this here is really highly depends on the kind of web framework you're using. JAX.js, for example, is very good supported by Swagger. Something like Regport, or even if you want to go away from this, like Liberator from Closure, there's mostly no support for this kind of thing. So the accuracy of your specification highly depends on what kind of web framework you're using, and you have a freedom of web framework. You don't want to say we are doing Swagger and therefore we are doing JAX.js. That's not the way to do it. And of course, you have no guarantee that your new IPA, your IPAs evolve, that they are still compatible with the old version. Yeah, sure, you generate your specification always in sync, but how do you ensure that the specification is in sync, is compatible with the specification of the last version? So the better approach would be to write the specification, and at best, if you write the specification even before you write any line of code. Especially RAML is something like this. In RAML, you usually write the specification before you write in code. And then, and this is the main part here, is you take the specification and use a property-based testing framework to generate tests out of your specification. And I'm using Scala-Check here because it's, in my opinion, the best property-based testing framework at the moment. So how does it look like? This here is a specification written in Swagger, for example. This is more or less in the first part, we just define what kind of URIs we support in our API, and what kind of responses we expect, what kind of parameters we expect. And the second part of the specification is the definitions of all the JSONs we are supposed to send. So now basically we have all information to generate arbitrary JSONs or arbitrary HTTP requests and see if we can deal with them. And that's the idea. We write a specification based on Scala-Check. I call it the Swagger-Check. And I tell it, hey, take a look at this YAML file. Then the first thing I would like to check, can I deserialize and serialize all my JSON according to my specification? And in my source code, I usually have some kind of value object or case class called author, for example. And in this case, I just say, hey, is my author sendable? This means when I generate an author in my application and deserialize to the outside world, does it verify to my specification? And this last part here is more or less just a JSON verifier. You just generate here an arbitrary case class, then deserialize it, and then deserialize it, create a JSON string, and then just see, is this JSON compatible with my specification? The other way around, and this is the other way around. Yeah, just as I tell my Swagger-Check here, as I just tell it, generate me arbitrary JSONs from my specification called author. Just generates really any kind of JSON which matches the specification, and then I try to parse it and validate it versus my author. And also I can check all my validation validators in my source code. And this here really, it doesn't look like much, but it was an eye-opener to me. Because this little line here generates really any kind of shit that is compatible with your specification. So if you, for example, say that you expect an UUID instead of a string, and then you use an UUID deserializer at this point, it breaks. And then you can say, hey, why haven't I specified that the string should be a UUID? I can specify it in Swagger. And the other way around, of course, there's tons of you actually check not only your model, that your model matches your specification, you also check if your specification is restrictive enough. You have tons of ways to specify formats in Swagger. Most people don't do it. They just say, hey, this is a string. But this is not enough. You can you can say it's an ISO-date format. You can say it's an UUID. You can give a Reka expression. And you can do all kinds of this stuff here, and this here forces you to do it. If you can't deal with this kind of JSON, then you can't deal it. Then you should probably fix your specification. Oh, it's bad. So, next part. This is something you probably just do in play, but it's also a really nice thing. You can test your router. You can see, hey, just give me any kind of requests that I can push to my API and see if I have a route for it. So this basically deals with any kind of typo I have in URIs. Also, in URIs, if you have URI parameters, like path parameters or query parameters, this will be dealt as well. You also check, can I really take all these request parameters and deal with them? And eventually, you can even go on. You can say, and this part here is you actually start testing your controller code. You dump in any kind of requests for this controller. Yes, as I told him, just give me anything the controller is actually listening for. Any kind of request is according to my specification. Dump it into my controller with some mocked DAO objects. Maybe can be the real thing even, and see, does it break? And it looks very simple, but real time it really breaks. If you have written a specification into I would really surprise if it not breaks. There's this more or less, and I added this last part here. This very old robustness principle: be conservative in what you do and liberal what you accept from others. In this case, you actually have a way to test it. Liberal means anything that's according to the specification, you have to deal with. You have to be able to deal with it in any way. You have at least be able to parse it. This is something you can test. And the other way around, I don't have an example here right now because this was supposed to be a smaller talk. You can also turn it around. You can say you have some kind. Let's say if you consume some other microservice and they have also a Swagger specification, you can of course generate tests to see if I generate code or JSON which is compatible with their specification. And this also addresses the point of backward compatibility, because all the tests I've written here, shown you, you can just duplicate with an older version of your Swagger file and see if your new version, if your new deserializers, serializers, routers, and whatever are still compatible with your old version. So the Scala-Check itself you can find on GitHub. This Cucumber, I don't call it library because it's just like 3 or 4 classes. You can find here, and eventually this putting it all together, this BookDB example is you can find on GitHub as well. And this was my talk.
Any questions?
Hi, thanks for the talk. Have you looked at API Blueprint? Because it's produced by a company named Apiary. And I think they also provide a testing framework. So you have the Blueprint, something like Swagger. And they have a tool that actually does this for you, that it tests the API, that it conforms to the API Blueprint.
We had tested it for... I'm not sure exactly why it wasn't for us. I think the main reason was that we had, in the current company I'm working in, Swagger is more or less what it's a given, and no, I can't really answer this why it wasn't the right thing. But we have taken a look at it, but it wasn't exactly this here.
Anyone else?
Hi, a great idea of this testing approach. It sounds to me like quick check. Is that correct, that this is the origin of this idea of just testing randomly properties? And I wonder if it would be available for other languages also.
Where was you? Where?
Over there.
Ah, sorry. So of course, the base idea is your property-based testing, right? You just, instead of creating fixed data, you just invent or guess. You just say, I have something, and give me anything that matches something. Yeah, and as I've said before, this year is very tightly bound around Scala-Check, because the project was put in play, Scala, so it just was the right tool. But I already was asked several times, hey, can't we use this for, don't know, Spring Boot, or for example. I'm not there yet. It's, in my opinion, it should be possible, simply, but I'm not there yet.
Yeah, I think I just heard once about it, and I think the original idea comes from microXchg, and which is Haskell-based. And I was just surprised that it's now getting adopted in different other languages, and I find the approach quite interesting.
Just as I said, this is I'm not sure where Scala-Check actually evolved from, but it wasn't from nowhere either. Well, the interesting part of Scala-Check is, of course, that it has this nice feature to generate generators from other generators. And so you can create complex things out of very simple things. Anyone can write a generator for arbitrary strings, but then generate a generator for JSON objects, well, it's tricky. Or generate a generator for matches for rig expressions. That's just actually the most complicated part in this here.
Any more questions?
Yeah, maybe I have one question about the integration testing. Are you using integration testing? So are you using integration testing in your organization? Because it seems
yeah, sure. This was more or less, this was not a real example, just an example. But of course, this is supposed to be an integration test. You deploy your application to a staging environment, then run this Cucumber test, where everything in staging with all the dependencies behind it, and then just see what happens, and it's red or green.
Yeah, so another question on top of this. I get the Cucumber, let's say, documentation generation part, but creating these mocks inside your application, which is testing your particular service, don't you think that it is like a double effort? Because you need to create this test and later you need to conduct the integration. So how hard it will be, so the question is, how hard it will be in your opinion to just skip this mocking part and just go straight to the integration test?
Sorry, this was probably a misunderstanding. This integration test always runs with the staging environment. So these HTTP requests are more or less real-world example. We don't do it versus production. We basically could even do it versus production, if provided you have some kind of test customer or something. This WireMock part was just, you just take your test, put a WireMock proxy in between it, and then record all your HTTP requests. And then you have a description for WireMock, which you can give your consumers and say, hey, this here is a mock of my service. This is a real-world recording. They take this and build it into unit tests. It's just something you can give other developers that they can use in their unit test. It's not something they should use in their integration test or something. It's just for just a way to give an updated version of your API as unit test helper to your other people. I think this packed framework is something which is doing something very similar, and I think you can even run a packed proxy instead of WireMock. Just WireMock is more simpler in my opinion, but it's just your choice.
Any more questions? Okay, thank you very much, Bodo.